Alright, so in this video we're going to use the max heap for insertion and deletion operation. Right now we're going to focus on insertion. Note the insertion and deletion operation is the same for min heap. The only thing you have to do is change the equal or lesser sign around. So again, the operation is the same for the min heap. All you have to do is change the less than or equal symbol around, and then you'll have a min heap in your code. Alright, so I build our max heap and the array. As you can see right here, that 1 is 70, 2 is 50, 3 is 40 in the array, 4 is 45, 5 is 35, 6 is 39, 7 is 16, 8 is 10, and 9 is 9. Now we want to insert a node. Let's insert, and it's important to also note that in a max heap and a min heap, or in a heap in general, you want to insert, you're always inserting on the left side of the tree. Again, you're always inserting on the left side of the tree to make it a full binary tree. Let me make note of that. So always insert on the left side of the tree, and insertion is always left to right. Important note. This is an important note right here. So you insert from left to right so the tree can be a full binary tree. Or you could say a full tree. Make an important note of that. Alright. So let's erase this right here. Okay. Now let's get the line and let's focus on the insertion. So we're going to insert on the left side of the tree. This is going to be 10 here. And we're going to insert the value 60. Now let's add it to the array. 60. And now what you're going to do here is, important rule in a max heap is the parent cannot be less than the child. Again, the parent cannot be less than the child. That's a rule. As you can see, the parent here, 50 and 40, the children are less than the parents. So, for example, here, if we look, 39 is less than 40, and 16 is less than 40. And if you go to the left side, the 45 is less than 50, and 35 is less than 50. And you can see it down there too, where 45 is less, 10 is less than 45, and 9 is less than 45. So what you're going to do here is we call this swapping. Okay. So now we're going to swap 35 and 60. So 35 goes to below. Let's make this a little bit smaller. Change this. 35 here. We're going to make this here 60. We're going to make this one here, make it black. We're going to make this one here 60. 60. Make it. I want to make this sure this is 60, and I want to fix the 35 here. Just want to make sure to show that this is 35. So 35 and 60. All right. But we will continue until we reach the top until we reach the root or the top of the tree. So is 50 greater than 60? No. So we swap. So let's here. And then we do a swap. This here. Quickly erase this here. This becomes 60. And this here below becomes 50. And that's how the insertion operation works. We went from bottom to top. Now let's do this in the array. So if you're doing this in the array, the equation to find the parent, this is how you find parent equation equals I divided by 2. That's the equation to find the parent. Let me just quickly spell parent correctly. Here, parent. Find here. So here for the insertion, you want to find the parent here. So you go 10 divided by 2, which is 5. So you can see here and here we do the swap, similar to what we just did into the tree. So let me make it clear for you guys. 10 divided by 2 is 5, and these are floor value. Just want to make sure to be clear about that. This is a floor value. So the equation is parent. I have to get used to this marker here. Parent and floor value is 10 divided by 2, or you could say I divided by 2 equals 5. And here is the floor. So here you could see that it is 3560. So now you do this switch. So I'll make this one small. This one here. Oops. See. $35. And this one in 5 becomes 60. 60. Okay. And now we want to check the value. So we do the parent value, we do the floor, and we go 5 divided by 2. It's going to be 2. So we then do the swap here. And then we do the swap here. This here. Erase it. 5 now becomes 50. And here. And 2 becomes 60. Let's make this one black. And right here, I just explained the insertion operation. Note that the equation to find the parent, I'm going to repeat this again, is parent equals floor I divided by 2. Take a screen capture of that. That's the equation you use. And this is how you do insertion. Alright, now we're going to focus on deletion.